In this video, I'm going to show you an easy way to make a CNC tool height touch sensor for CNC plasma or a router using an Arduino water sensor from Amazon. Just search for Arduino water sensor and look for these with a separate ground probe and this little blue control module. This is the one I used. These have a digital output, and that's what we want. The circuit has a 2-pin header for the probe, which is from ground, and this is the probe. And the probe input is connected to the shield on a plasma cutter or to a fixed or removable touch plate on a router. And when the probe makes contact with ground, it triggers the circuit. On the other end of the board, there is a 4-pin connector with power, ground, digital output, and analog output. But the analog output is useless because that's the same as connecting directly to the probe. It uses an LM393 comparator to detect when the probe makes contact with ground or partial contact through resistance by comparing two voltages, the voltage on the probe and the reference voltage on this pin. Whichever voltage is higher controls the digital output. Normally, when the probe is not contacting ground, this 10K pull-up resistor applies 5 volts on this pin, and this 10K pull-up resistor applies 5 volts on the digital output. And the reference voltage is determined by this adjustable 10K trim pot, which forms a voltage divider between 5 volts and ground. When it's in the middle, we have 2.5 volts for reference. So the probe starts at 5 volts, and when it makes contact, it drops to near 0 volts. That makes the reference volt higher so that it takes over and drives the digital output low to signal a detection. So the digital output will be connected as an active low input to the breakout board. We only have about 3 volts of adjustment on this sensitivity setting. If you crank it all the way down or all the way up, the comparator will either lock off or lock on, and then it won't work. So for detecting metal, we crank it up as much as we can, and that gives us about 4 volts on this pin for the reference voltage. So the probe has to drop below 4 volts to detect contact. On clean metal with a good ground connection, that's not a problem because there's very little resistance or insulation between the probe and ground. But for plasma cutting, the metal may not have good ground contact and it may have rust or mule scale, and those are not conductive, so it cannot detect through thick rust or thick mule scale or paint or any other insulation or high resistance between the probe and ground. That's usually not a problem on a router because it's easy to keep the touch plate clean and well connected to ground. But on a plasma cutter where there may be a poor ground connection or thick rust or mule scale on the material, you really need a breakaway torch mount or a stiff floating Z-axis to stop the tool from moving down if this fails to detect. I discussed that a little bit in this topic on my website. But I won't get into that in this video. You can use this like it is out of the box on clean metal, but we need to bump up the sensitivity to detect through light rust and light mil scale as much as we can. This 10K resistor that holds this input at 5 volts means that we can only detect ground through less than or about 10K of resistance. If there's more than that between the probe and ground, then it will not detect, because this resistor holds this at 5 volts. So what we need to do is change that resistor to a 1 meg. You can replace it with a size 0805 surface mount resistor, or you can use a 1/8 watt resistor with leads if you stand it up like this. All you have to do is put your soldering iron up against that resistor and push sideways, and when it gets hot, that thing will go flying. And you just put a 1 meg resistor in its place. It's interesting to note that the picture on Amazon does not match the actual board, because it has 2 resistors between 2 capacitors, and this shows 2 capacitors beside 2 resistors. But that's how Amazon listings are. They're not 100%, as we will see here in a minute. Now we can detect less than or about 1 meg of resistance between the probe and ground. And that helps detect through light, rust, and mil scale. But now 5 volts through 1 meg doesn't have a lot of current to get electrons to move from ground to the probe through rust or mil scale. So the next thing we need to do is change the voltage from 5 volts to 12 or 24 volts. And that will give our probe much more power to detect ground through a poor ground connection and light, mil scale, and rust. And on Amazon, this circuit is rated for 3 to 5 volts, but this chip is rated for like 2 to 32 volts. And best I can tell, everything does and should work just fine 24 volts, except for the connection to the breakout board. Some breakout boards may be able to take 24 volts on the input pins, but unless you can confirm that in the data sheet or somehow, we will have to add an optocoupler module to convert the 24 volts down to 5 volts to connect to the breakout board. And if we search on Amazon for Arduino optocoupler, we can look for PC817 and EL817 based optocoupler modules like this. And you will find a whole bunch of different listings for basically the same board. And they all do the same thing, even though these 2 listings jack up the price. And this one makes it sound like you need to choose between 5, 12, and 24 volts. And this one is rated for 12 volts. And one shows it connected as an input, and the other one shows it connected as an output. But they are all good for 3 to 30 volts, and they can be used for an input or an output. And I would choose this one because the listing is a little clearer and the price is better. And it shows that it can be used as an output to the breakout board. We are going to connect it to our 24 volts, and our digital output will switch it on when it goes negative, and that will drive the output to the breakout board to negative. Otherwise, when the probe is not detecting, the output will be 5 volts or whatever we have connected to the breakout board. When the probe is not detecting, we have 24 volts on the output. So we have 24 volts here and here, so it doesn't do anything. And when it detects contact, it goes negative. So that activates the optocoupler, which switches the output to the breakout board from 5 volts to ground. So it works the same way it did before. It's an active low input to the breakout board. So now we have a pretty good tool height touch sensor, but there is a limit to how much poor ground connection and rust and mil scale it can detect through. So you'll have to test that and use it correctly. And on a plasma cutter, this probe is connected to the shield on the plasma cutter. So it is a good idea to wire that probe through the relay that turns the torch on, so that when the torch comes on, the relay disconnects the probe from the touch sensor circuit for what it's worth. And then you do have to configure that input as active low. And you do have to configure your post-processor to issue a probe down on the Z-axis in between cuts, and then zero the Z-axis before moving to the pure site. And with a router, there are any number of ways to set up manual or automatic tool height detection. I can't cover all that in this video. And one more thing, if you buy like a 5-pack, you can use these extra wires to make all the connections. If you want to discuss it, this will be at readytocut.com in the CNC snack bar. In basic height control, there will be a thread here for this new height sensor. And there's lots of information here about CNC. And there's lots of free files with preview images and categories. And I also do custom requests for CNC art. And you can find my retail cutting files at signtorch.com. So let me know how it turns out. That's all for now. I'll see you next time.